Hello, in this video we'll talk about descriptive statistics. So first of all, let's get a sense of the distributions from the data. One common way people do this is frequency distribution. So basically you summarize your data, which shows how many of the observations are lying in each of the non-overlapping bins or categories. Now look at this histogram. So on the vertical axis we have the frequency. On the horizontal axis, you will usually have your bins, and it plots what is the frequency for every single bin. You would see here that the population mean for this histogram is 10. Now, a measure of central tendency is a single numerical value that aims to describe a data set by simply identifying the central position within the data. We use this very commonly in descriptive statistics. So the three common measures of central tendency are mean, median, and mode. So mean is a simple average of numbers or variables. You can calculate that by summing all the values, divide by total number of observations in that data set, and you get your arithmetic mean. Median is basically the middle value when the data are arranged in ascending order. So if you have odd number of observations, simply just take the middle value. If you have even number of observations, then you can average the two middle values. For mode, you need to know what's the value that occurs most frequently in a data set. If you are looking at a histogram, then whichever is the tallest bar, that is your mode. Another descriptive statistics that's of interest to us is the measures of dispersion. So again, there are multiple ways to get an idea of the dispersion. The first one is called range. Range can be found by simply subtracting the smallest value from the largest value in a dataset. We all know just take the maximum minus minimum value in the dataset. Variance is a measure of variability that utilizes all the data, and standard deviation is just positive square root of the variance itself. And you can see the formula for calculating these. In addition, sometimes we also use mean absolute deviation to measure dispersion in a dataset. It is calculated by measuring the absolute values of the differences between each data point and the mean and then summing them up. Let's have a look at the box and whiskers plot, which does a great job of showing the quartiles. A quartile is a quarter of the number of data points given in a given set. It expresses how many percentage of data lies in that range. So if you look at the box and whiskers plot here, there may be some outliers in the data. So let's exclude the outliers right now. So this is the minimum point, is the smallest value excluding the smaller outliers. And then you have where the box starts, or the lower point of the box shows the lower quartile or the 25th percentile of the data. It means that 25% of the data is smaller than this value. Then we have the median. Median is the second quartile, or 50% of the 50th percentile, meaning 50% of the data is larger than this value, 50% is smaller than this value. Then we go to the upper quartile, which means 75% of the data is below this value and only 25% of the data sets are larger than this value. And where we have the top whisker, this is the maximum or the largest value excluding the outliers. So outlier means values which are much higher or 1.5 times higher than the other values, than the lowest value or the most maximum value in this set. So we may have some outliers or some exceptional values in the data set. Usually when you draw the box and whiskers plot, it excludes those outliers to frame the graph. Histograms are a common graphical representation of quantitative data to show the frequency. It also helps us to get an idea of the shape of the distribution. So, two things that we typically measure to understand the shape of a distribution are skewness and kurtosis. Skewness is a measure of asymmetry or sway in the distribution of data. So let's have a look. If this is a symmetric distribution, then a left skewed data will have a tail towards the left. In such a case, most of the data is lying towards the right hand side. A right skewed data has a tail towards the right hand side, and most of the data is towards the left hand side. So this gives a pretty good idea of what is the shape of the distribution. Kurtosis, on the other hand, talks about if your data has a higher peak, is it tall, is it skinny? So that nature of the data distribution. So if you look at the symmetrical data, the one in the middle, so that's the normal distribution. But if you have a positive kurtosis or a higher kurtosis, the data will have a taller peak. But if the data is flatter compared to a typical normal distribution, this is a negative kurtosis. So you can say if it's flatter or skinnier or taller. So let's quickly have a look at these. So we have charts A and B. Let's think about what is the difference between the mean of A and B. Well, both the means are lying at 0. No difference. In terms of kurtosis or the shape, well, chart A has a taller peak in terms of kurtosis, so positive kurtosis compared to B. Skewness, well, we see both of these charts are symmetrical. So skewness, there is no skewness, left or right. What is the difference between C and D in terms of mean, mode, skewness? So let's examine these two. Now we can see that this is definitely the mean for the chart C is lying about here, which is at -2, and the mean for chart D is lying at +2. So these two have different means. Chart D, the mean is higher. Mode is represented by the tallest bar. So for chart C, the tallest bar is again at -2, and for chart D, it is at +2. So again, same thing, our mode are different. D has a higher mode. So for D, mode is 2. Here the mode is -2. In terms of skewness, we see that our data is not symmetrical. The shape is not symmetrical. So chart C has a tail going towards the right hand side. So what kind of skewness is this? Like we said before, this one is a right skewed data. And then chart D, there is a tail towards the left hand side. So this one is a left skewed data.